when we have 3p3, you can say 3 pick 3, you can say 3p3, whatever. It doesn't mean pick, it means permutation. So it means the objects that you're picking, the order matters. So for example, the difference between 3p3 and 3c3 is, this one is a perm, this is a com, permutation combination. Permutation order matters. So you have 3 objects, I'm picking 3, but what am I doing? I'm arranging those 3. This one I have 3 objects, I'm picking 3 and then I'm done. So an example of the differences for a permutation is I have a group of 3 people. Those 3 people I'm arranging, I'm going to pick those 3 people and then I'm going to arrange them in a line for a picture. Permutation. Combination. I have those 3 people, I'm just picking all 3 of them and we're going on a trip. So this one's a combination. The order in which I pick those 3 doesn't matter, they all get to go on the trip. Okay, another example would be, I'm going to come to you guys in this class, there's 13 of you, and I'm going to say, hey guys, 3 of you get to go on a trip. Okay, I'm picking out names, 3 names out of this class, and you get to go on a trip. Difference between perm and com, permutation. I'm going to pick 3 names out, you're going to go on a trip. The first person who gets picked out gets to go to Hawaii. The second person who gets picked out gets to go to Edmonton. And the third person who gets picked out gets to go to Sobeys in Okotoks. Does the order in which you 3 get picked matter? Yeah. Me too, thanks. I like food though. So Sobeys sounds great. And I don't like flying, so there you go. Sobeys is still a win for me. Then you get a free shopping spree to eat whatever you, yeah. Oh yeah. Thank you. So, does the order in which the 3 of you get picked matter in that instance? Yes, so it's a permutation. However, what if I say, okay, there's 13 of you. You get to go on a trip, 3 of you, okay? I'm picking 3 of you to go on a trip. All 3 of you get to go to Sobeys in Okotoks. Does it matter if you picked first, second, or third in that? No? If you're picked first, you're just like, yeah, I get to go to Sobeys. You're gloating for a little longer, but that's about it. If you pick third, you still get to go to Sobeys. You might be like, oh, please pick me, please pick me, please pick me by the third one because you know it's the last pick. However, it is no different. You still get to go to Sobeys in Okotoks. We agree? Okay, that's a combination. So if the things that you're picking, the order does not matter, if you are no specialer, if you're picked first or last, no more special. I like specialer personally. First or last, then it's a combination. Okay? So another example would be we get to go to student council. We have student council, and we want to pick a 3-person subcommittee for student council, okay? The 3-person subcommittee, now you're going to tell me if it's a permutation or a combination. I have a student council, and I want to pick a 3-person subcommittee. Combination or permutation? Combination. You're either on the subcommittee if you're those 3 people, or you're not, okay? Student council. I want to pick a 3-person subcommittee. The first person has to do the treasury part of it. The third person or the second person gets to tell everyone what to do, and the third person has to clean up the room when they're done. I like making great options. Permutation or combination? Permutation, because the order matters. I would want to be the person telling them what to do. I wouldn't want to have to like clean the room up after. You know, people could just throw stuff like dirt. I don't know where they get the dirt. They could throw it. Be all up in that. Okay. So understand the difference between permutation and combination. So I'm going to give you examples. You're going to tell me if it's a perm or a com. License plates. Perm. Why? Right. If I'm BBF and someone who stole a car is BFB, I don't want them thinking we're the same people. Correct? Also, there would be way less license plate options if all of those meant the same thing. Right? What about picking out vegetables to go in a salad? Perm or a com? Com. Because, yeah, throw them in the salad and you get the salad. Making a pizza. Although you may think the order matters on a good pizza, it doesn't. Because you still have all the same things. Weirdly, the pizza would be really creepy if it was like cheese, pizza sauce, crust. However, you'd still have a cheese pizza. So it's a combination. That one always gets people. What about chili? Picking things to put in chili. Oh, but you can. Combination. You still could throw it all in there and turn on your Instapot. Yeah. Now that the Instapot is here, you have nothing on me. Like, toss it in, Instapot, boom, and they're like, oh, but it's not a good chili. I didn't say we were making a good chili. I just said a chili, nonetheless. Okay? It could be just meat and beans. Be really grossest chili ever. Really grossest. I'm so good at all this English right now. It's just great. You can go back and listen to this. It's just, there's so much goodness going on right now. Yeah, thank you. Kindred spirits. Okay. What about the code for your debit card? Order matters, right? Code for your house. Permutation. So basically codes are permutations, right? If your code to your house is like 1753 and you put it in a different order, you ain't getting into your house, right? What about words? Permutation, because pool and loop are not the same thing. Neither is opal or lopo or oopla, you know? All these options. Oopla. Yeah, makes sense? Got it? Okay. So, combinations. Discuss how throwing 3 toys into a bag is different than lining them up. What's the difference? I'm going to take 3 toys, I'm going to huck them in a bag, or I'm going to take 3 toys and I'm going to be like, hello, little toy, you sit here. Hello, little toy, you sit here. And hey, little toy, you're my worst toy, I'm going to put you here. What's the difference? Yes, order matters in the last one for some weird reason. So, what's the difference between them? Throwing 3 toys into a bag is a combination because they're either in the bag or they're not. If you can say you either get to go on the trip or you don't, you're either in the bag or you're not, any of those things, then it's a combination. If the order matters in which you're doing that, then it matters. So example, and then lining them up is a permutation. Why does it disconnect every so often? Come back. Okay, what happens if I go to a library and I get to check out 3 books? Here's my 2 options. First option, I go to the library, I get to check out 3 books. I go to take my 3 books up to the counter, and the librarian's like, you have a book out. You are only allowed to take out 2 books at a time. So you are only allowed to take out 1 book right now. And you're like, but in the next 3 months, I need these 3 books. And she's like, too bad, bring back books. You can only take 1 out at a time. So you go up to her and you pick 1 book. How many options do you have there? You have 3 books, but you can only take out 1 at a time. Is it a permutation or combination? It's a perm because the order matters. Because you only get to pick out a certain book. So for the first month, you have how many options? 3. You return your book. Next month, how many options? 2. Next month, how many options? 1. So you can use the fundamental accounting principle to solve that. But you can also use the fundamental accounting principle to figure out how many different options you have for a sandwich. We agree? And a sandwich would be a combination. So the fundamental accounting principle is just a method to solve perms and coms. It isn't a separate thing. Permutations and combinations are opposites of each other. Fundamental accounting principle is an option that you can use sometimes to solve things. Okay? Now, I go to the library. I've returned all my books. The librarian's like, you know what? You're a good kid. You could take all 3 out at once. Permutation or combination. Because you take the books, you toss them in your backpack, and you go home. Right? You don't organize them in a certain order in your backpack and therefore can only read them in that exact order that you put them in your backpack, right? They're either in your backpack or they're not. You got to take them home or you didn't, right? So that would be a combination. Another thing to note, this is the formula for a combination. We see that? Okay. Now, 10C6 down here says, they say equals 10C4. Now this only works for combinations. This does not work for permutations. Do you notice something between these two? 10C6, 10C4. Is there any kind of correlation between them? Yeah? Yes, 6 plus 4 equals 10. So if I went 10P6 equals 10P4, 4. This is not true. Why? Because you told me to? No, there's a reason. So I'm going to show you. The formula for P and PR doesn't have this R factorial on the bottom, does it? It is everything but that. We agree? So we're going to fill the 10C6 into this formula and see what happens. So 10C6, 10 goes in for the N's and 6 goes in for the R's. So I'm going to get 10 factorial over 10 minus 6 factorial, 6 factorial. We agree? Which is 10 factorial over 4 factorial, 6 factorial. We agree? Yeah? Okay. Equal sign. Now we're going to do this formula with the 4. 10 factorial, now R is 4. 10 minus 4 factorial, 4 factorial. So it's going to be 10 factorial over 6 factorial, 4 factorial. Are they the same? Yeah. Because you put brackets around the denominator, correct? So does it matter if you multiply this way? If you go, and you've learned this since grade 3, 2 times 5 and 5 times 2 is the same thing, right? You can order them all you want. The ones, and like 5 plus 2 and 2 plus 5 is the same thing, right? Addition and multiplication order doesn't matter. Division and subtraction order does matter, right? If you go 5 minus 4 or 4 minus 5, you get totally different answers, right? If you do 24 divided by 6 or 6 divided by 24, you get totally different answers. But multiplication and addition, it doesn't matter the order. So that's why when you actually figure out the difference between the two, you get the same answer. So say I gave you 20C5. What would that be equal to? 20C15. Just the difference between the two. Okay? Why does P not work out? Because you just have 10 factorial over 10 minus 6 factorial, which is 10 factorial over 4 factorial. There's no R there, right? And then this one would be 10 factorial over 10 minus 4 factorial, which equals 10 factorial over 6 factorial. They're not the same, right? The only reason why it works with C is because it has that extra R factorial in the back. Does that make sense? Okay. Another thing to note is I can write them like this. Instead of 20C5, I can write it like this. Because NCR is the same as NR. And if you forget, they actually tell you that. It only works with C's. So if your answer was 10C5, they could, as a multiple choice, just put in brackets and go 10-5, right? It's the same thing. It's not a P, it's only a C. P does not give you the same thing. Does that make sense? So if your answer was actually your group, and I picked 3 of you to go on a trip, all going to Sobeys and Okotoks, right? Your answer would be 13C3. We agree? Which is actually the same as what? 13C10. So could they put the answer 13C10 on your diploma? Yeah? Because it's the exact same answer as 13C3. So you have to know that. Yeah?
So if you had 10 books, you can only choose 3 of them. Is that common?
It depends on what you're doing with them. Are you picking all 3 of them at the same time, putting them in your backpack and going home?
So if you're only picking one at a time, that makes a difference?
Yeah. If you can't take all of them home with you at once, it's a permutation.
Even if there's 10 books?
Yep. Because the 10 picking 3 isn't the issue. That can get you a C or a P. The issue is those 3 that you're picking. You have to look at the second, the R, and if that R has a matter, has an order, a matter, what's that? If it has an order, if order counts, if order matters, then it's a permutation. If those 3 order doesn't matter, it's a combination. So we don't actually really care how many you have as an option. That just helps you find the answer. What we're looking at is that R value. If that R value has an order that matters, it's a P. And if the R value doesn't, it's a C. Okay, let's look at some examples. So when you have restrictions with combinations, it alters what you're choosing from, so you have to remember that. You don't just do that first, it just alters the amount. So 3 students from a class of 10 are to be chosen to go on a school trip. How many ways can this be selected? What do we get? How do we do this? How many do we have to choose from? 10. Is it a perm or a comp? Look at the 3 students. They're going on a school trip. Did they say specifically different? Do they just get to go on the school trip or they don't? If you're the fourth person, you don't get to go. If you're first, second, and third, you get to go. Are you any special or are you any special? I really like that word, even though I don't think it exists. Are you any more special if you're first, second, or third? No, you get to go on the trip. So it's 10C3, which equals 10C, which equals 10(3), which equals 10(7), which equals 10 factorial over 3 factorial, 7 factorial when you fill it in, right? Could any of these answers be there? Yes. Could the actual answer be there? Yes. So go 10C3 into your calculator. Instead of picking 2 for the P, where you were in math, you're going to pick 3 for the C. What'd you get? 120? Now go 10P3 just for fun. Because, let's see, 720. So 10P3 gets you way more answers than 10C3. Why? Because order matters. Once you start organizing and ordering things, then you're getting way more options, right? So if I take those 3 people and I get to pick them, they get to go on the trip or they don't, we're going to have way less options than if I pick those 3 people and now I have to order them. Okay? To win the Lotto 649, a person must correctly select 6 numbers between 1 and 49. The catch on the Lotto 649 is the 6 numbers can be picked at random, and if you have those 6 numbers, you win, right? Can you imagine if the 6 numbers you had on your ticket also had to be in the order in which you picked them on the ticket? It would be ridiculously hard to get, correct? So 1 to 49, how many numbers is that? 49. If you can't envision if it's 49 or 50, think of something smaller. 1 to 2 is 1, 2, 2 options. 1 to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Is 9 options. So 1 to 49 is 49 options. So we have 49 options. Is it a P or a C? How many are we picking? 6, which is the same as 49C, which is the same as 49, 6. Which, oops, what multiplication almost there. Which is the same as 49 over 43, which is the same as 49 over 6 factorial 43 factorial. Or 43 factorial 6 factorial. I'm just showing you all the options because they could give you any of them, right? And if you're like, it's fine, I'll just get the answer and then I'll match them. What if they have a really big number and it doesn't let you do it? Then they keep it in the numbers, right? You need to know all your options. Plus, it can be unwritten response too, right? Okay, this is where it gets a little harder. The athletic council decides to form a subcommittee of 7 council members to look at how funds are raised. How funds raised should be spent on sport activities in the school. They're picking 7 council members. If you picked first, second, third, fourth, fifth, sixth, or seventh on that council, does it make you any different? No. It would change if they gave those 7 council members jobs, different jobs, right? Did they give them different jobs? No. So we know it's a combination because they don't have jobs, different jobs anyways. There are a total of 15 athletic council members. So 15 total. We're choosing 7. There are 9 males and 6 females. This is the catch. The subcommittee must consist of exactly 3 females, which means what? When they say exactly 3 females, they're telling you 3 females and exactly how many males? Nope. 4, because our subcommittee is made up of 7. Right? So we want to choose 4 females, and we want to choose, sorry, that's 3 females, not 4. 3 females, and we want to choose 4 males. We agree? Why did I pick a C? Not because of the word choose. I just say choose. Why did we pick C? Yeah. Right. Yes. I did like that statement because it was funny. Yes, despite the fact that they're male and female exactly, the order in which you pick those males and females doesn't make them any more special. They are just on the subcommittee. So if you can say, I'm on the subcommittee or I'm not on it, you're not any more special if you're picked first, second, third, fourth, fifth, sixth, or seventh. Yes, that's completely correct. Now, we have to decide, how do we guarantee getting females? So we're choosing 3 females, but how do we guarantee that we're going to actually get females? What do we have to choose them from? The females. Yeah. So we have how many females? 6. And we have how many males? 9. Now we have to decide, do we multiply or add? Do we need the 3 males and the 4 females to make the subcommittee? Or do we need the 3 males or 3 females or the 4 males to make the subcommittee? We need an and, right? Because we need 7. So if we want and, we need to do what? And we do what when we say and? Multiply. So let's type this into our calculator. 6 math. C. I forget 3 times. Was it 6? And then 9? Hopefully. 4? 2,520. Would it make a substantial difference if the order mattered in which I was picking those people? Yeah, because now I'd pick them and then I'd have to order them. Makes it totally different. If it says, in how many ways can the subcommittee be selected if Bruce, and it should say the male football coach, must be included. So we have to have Bruce. What's the only way we can guarantee getting Bruce? Choosing from? What's the only way we can get Bruce? Choosing from? Nope, not males, because we could get other people other than Bruce. Choosing from a group of Bruce. How many Bruce is there? 1. So to get Bruce, we're going to have 1 Bruce and we're going to choose him. Quite complicated, right? You're on the team. All right. Now, we still need what? 3 females. We need Bruce and 3 females. And these are my and symbols. And what? 3 males. If we do 4 males, how many do we have on the subcommittee? Yes, which means we'd have 8 people, and we only need 7. So we have Bruce, we have 3 females, and we have 3 males. Most people are good with this, and they mess up in the next little step. How many females do we have to choose from? 6. We choose 3. What about the males? 8, not 9, because we already have Bruce out, right? So we have 9. Oh, 8. I just said not 9, and I wrote 9. 8. Choose 3. 1 choose 1 is just 1. If I have 1 and I choose 1, there's only one way to do that. Bruce, come here. You know, like, done. Okay. So it's really 63 times 8C3. Does anyone have that? 63 times 8C3. What did you get? So we have substantially less options, right, once we picked Bruce. Okay, standard deck of cards. If I ask a card question, I have to give you the array. They have to explain to you what the cards are. They can't assume that you know what's in cards. There's no like assumption for grade 12s. You must know all what's in a deck of cards. Okay, so either they'll give you an array of the cards if they ask you a card question, or they would make up a totally different deck of cards that no one's ever seen before. There's 4 suits, green, blue, purple, orange, and they're the numbers 1 to 5. Like totally different, neutral to everyone. Like a what? Yes, exactly. I love Uno. I also really like, I just really like cards. Oh, Skippo. Love Skippo. You ever played Skippo? Oh, missing. You can't, you've never lived until you've played Skippo. I will bring Skippo. Because I feel very bad for you right now. You've never lived. Like, you think you have, you haven't. Skippo's pretty awesome, isn't it? Yeah. Okay. Standard deck of 52 cards. There's 4 suits: spades, clubs, diamonds, and hearts. Each suit has 13 cards, which means there's 52 cards in total, because 13 times 4. 2 suits are black, spades and clubs. So how many black cards? 52 divided by 2, 26. How many red cards? 26, half the deck. Face cards considered to be jacks, queens, and kings. If you look at a deck of cards, they're the ones with faces on them. Face cards. Okay. Poker is a card game played from a deck of 52 cards. How many different 5-card poker hands are possible? Cards are always combinations, because when you pick the 5 cards and you put them in your hand, or however many, 8 cards and you put them in your hand, do you have to play them in the order they were dealt to you? No. Once they're in your hand, you can move them all around, right? So when you're waiting to get a card hand and someone's dealing it to you and you look at your cards, right? You're like, oh, and you're like, oh, come on, give me that card for the 5th one. Does it matter if you're 1st or 5th? No, it's in your hand. You can use it, right? You might be like getting a little feverish by the time you get the 5th one. You're like, come on, just give me an ace or whatever it may be. But once they're in your hand, you can move them all over, right? So the order in which they're handed to you doesn't matter. Those 5 cards, once you get the 5 cards, you have them, you can order them all around. I just realized this finger's way shorter than the rest. This is how my brain works, just so you know, functioning throughout life. I talk and then I realize things like that, and then I come back. Look how much shorter this is than the other 2. You know what else I realized? I jam my middle finger on this hand so often in volleyball, and when I was diving back to my base in baseball. I jammed it this year. But look, it's like substantially taller. It like needs a helmet, right? Look at it. It's disproportionate. This is way taller, and that's why I jam it. It needs its own little helmet. That's what I've decided. Or bodyguard. I don't know. Like you need to get a mouth guard. Why can't I have a bodyguard for my finger? Hmm? 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 Give me that look, but you think about it. Both. Okay. Then maybe it wouldn't get jammed. I don't know. I like that. I need my own secret service for my finger. Yeah. They'll like stop and be like, wait, this is a dangerous situation. I will block for you. And I'd be like, okay, good. All right. 5-card poker hand. How many do we choose from in this case? How can we guarantee getting 5 cards from the deck? 52, right? We don't, if we had needed a specific red, or we need a specific club, or we need a specific spade, then we'd have to choose from spades or clubs or black cards or red cards or 4s or 7s or jacks. But right now I just need 5 cards from the deck. So that's what I'm going to do. 52C5. And it's a number. Right now I don't care what that number is, because that could be the answer on your diploma, right? Just 52C5. Or 52C40. Yes. Okay. Now, in how many ways can there be all diamonds? We're still only picking 5 cards, right? It's a poker hand. There's 5 cards. That doesn't change. Just like the subcommittee before was 7. Didn't change. I need all diamonds. So that means I need 5 diamonds. We agree? Cards are always combination. So how many diamonds are there? So I have to choose from diamonds, right? 13C5. Or 13C. Yep. Now, 2. 4 black cards, 1 red card. What would it be? How many black cards do I have to choose from? 26, half the deck. Choose 4. And, because I need 5 cards total, right? So I'm going to have to multiply, because I need the 4 cards and the 1 card. Or I don't have a deck of, or a hand of 5. I have a hand of 4 or 1, which is not helpful in poker. They'd be like, come back, get another card, or 4 more. And a red card, how many options? 26. Choose 1, and then I get my answer, right? 3 kings and 2 queens. How many kings? 4. because you have one in each suit. So 4 choose 3. And queens? 4 choose 2. These are most people are okay with. Then we get to 3 kings. So everyone's like, 4 choose 3, move on. That's the answer on your diploma. It is. It's wrong. Why? I still need 2 more cards. This is the catch. 3 kings means exactly 3 kings. That means, could I possibly pick the 4th one as well? If they want 3 kings? No, we have to kibosh that. We have to say, nope, can't have that 4th king. Okay? So really what they want is 3 kings and 2 others. 2 other cards than kings. We agree? How many other cards are there than kings? 48, yes. Some people want to say 49. We still have a king we could use. Can we use the other king though? No, then we chance getting 4 kings. Do we want to have 4 kings? No. So we'll do total minus the 4 kings off. So I have all the other cards to choose from, which is 48. What about 4 aces? How many aces are there? 4. And I choose 4, so I'm done. No, what do I need? 1 other. How many others are there than aces? 5 cards of the same suit. So if I said 5 clubs, you would tell me what? 5 clubs, what would it be? 13 clubs, I choose 5. Okay, but did I say clubs? No, same suit. So I can have clubs, or I can have diamonds, or I can have hearts, or I can have spades. Why am I saying or and not and? Right. Because if I said and, I wouldn't have a 5 card hand. I would have a 20 card hand. I'd have these 5 and these 5 and these 5 and these 5. Do I want 20 cards? No, I'd have a good chance of winning. I would have nothing left for the other people. But I don't want 20 cards. I want 5. So plus, and this would be 13C5 plus 13C5 plus 13C5. Or how else could I write it? What's 13C5 plus 13C5? How could I write that in a shorter form? Or they could write it as, or 13 and 8, right? It's the same thing. Ultimately, the answer is the same. These, what you need to know is that this number here needs to be smaller than the n. R was R, so n always has to be greater than or equal to R. We agree? The n always has to be greater than or at least equal to what you're choosing. So if I'm choosing 3 things or I'm picking 3 things, I need to at least have 3 things to choose from or pick from, right? So your n has to be greater than or equal to. So the answer's there if you want to try them. I wouldn't care if you just use your calculator. Last thing we have to go through is at least or at most. Okay? So all we've done so far is we've done exactly 3 females or exactly 7 people on the committee, you know? But now we're going to do at least or at most. So if I say I need at least $5 to buy something, if I need at least $5 to buy something, I need $5 or more. If I need at most $5 to buy something, I need $5 or less, right? So at most means less than it, that value or less. At least means that value or more. Okay. So this one says we have 12 adults, 18 kids on the prom planning committee. A smaller group of them, 5 people only, needs to decide on the themes. We need a 5-person group. Is there anything special about being first, second, third, fourth, or fifth in that group? Nope. So it's a C. How many different ways can this smaller group, the subcommittee, consist of at least 4 adults? So we need 4 adults or or more. We agree? So I need 4 adults or 5 adults or 6 adults. We stop at 5 what? Because we only have 5 people on the subcommittee. So this subcommittee, great, we have 5 people. This subcommittee needs more. It only has 4. So we need 4 adults and what? What's the other options? Yeah, a kid. So we need 1 kid. Yep. No, because this is a case where I have to have exactly 4, because this one already has 5. Each of these cases are exact cases. So if I need 4 adults or more, this case is where I have 4 adults, and that's it. This case is where I have 5 adults.
But like, would it still be? Because like, if it's 12C4, then you're guaranteeing you're picking 4 adults out of 12 pool. Then the other one doesn't matter if you have 5 adults. You know what I mean? So why do you have to separate?
Because you have to do specific cases where you, because that one isn't encompassing the 4 adults. That one's encompassing the 5 adults possible. It's like the same thing when we did the evens, where we had to do a case with a 0 and a case with a 2, 4, 6, or 8. Right at the back?
All cases would be relevant, right? Regardless if it's a kid or 5 adults.
Yeah, but we have to do the cases where it's a kid or a case where it's not a kid. Just because which one case you might pick the kid and one case you might pick the adult. So you're not going to get all the cases.
But you always have at least 4.
But we need 4 or 5. But you're not going to have a case where you're going to have 4 or 5. You're going to have the case where you're going to have 4 or you're going to have 5. You're not going to count both when you do it your way. You're going to pick specifically this case or you're going to end up picking this case. You're never going to pick both cases with your method. So you need cases to get all of the different ones. Just like we could have done 0, 2, 4, 6, or 8 as our back blank for the evens, but you're either going to pick 0 and then get a different answer, or you're going to pick the other ones, 2, 4, 6, or 8, and get the other answer. But you're never going to get both if you don't do it in cases. Same thing here. So you have to do it in separate cases so that you always get both. You'll be short if you don't. Okay. So how do we guarantee getting an adult? Choosing from the adults. So we get 12C4 times 18C1 plus 12C5. $9,702 is what I got. I did it really fast. Did you get that? Yay or nay? Okay. So, if you flip over here, this is your homework for it.